Okay, today's lesson is only 3 templates long. How do you find the sum? We're going to find the sum of an infinite geometric series. Think about what I just said right there. Find the sum of an infinite geometric series. How do you find the sum if it's infinite? Infinite means it goes on and on and on and on forever. I'll show you how you can find the sum of an infinite geometric series. And it's the sum of an infinite, there's a little infinite sign right there. The sum of an infinite series, all you need to know is the first term divided by 1 minus what the ratio is. But there is a stipulation. The ratio must be less than 1, the absolute value of that. What that means, it must be a fraction then. If the ratio is a fraction, you can find the sum. So there's the formula. There isn't much to it. But there is a stipulation. The ratio has to be less than 1. It must be a fraction. If the ratio is equal to 2, you can't find the sum. There is no sum. Only if the ratio is a fraction can you find the sum. Okay, so there's only 2 parts for today's assignment. There's only 3 templates. A converging series. You can find the sum. If it's a converging series, you can find the sum. A diverging series, the series keeps going and keeps getting bigger and bigger, and you can't find the sum. So part 1, this is all you're doing in part 1. Tell me if the series diverges or converges by finding the ratio. I want you to find the ratio, and I know you wouldn't have to even find the ratio. It's up to you. You don't have to find the ratio. A diverging series is when the series keeps getting bigger and bigger. Well, what are these numbers getting smaller, or are these numbers getting bigger? If the numbers are getting bigger, it's diverging. If the numbers are getting smaller, it's converging. So these numbers are getting smaller. The numbers are getting smaller. It's converging. The numbers are getting bigger. It's diverging. This one's diverging. The numbers are getting bigger. That's it for the first part of the assignment. Look to see if the numbers are getting bigger or if the numbers are getting smaller. I think you guys can handle the first part. Second part of the assignment is to actually find the sum if you can. So, if the numbers are getting smaller, you can find the sum. It's called the converging series. If the numbers are getting bigger, there is no sum. And if the numbers are getting smaller, you are going to use this formula right here. The first term divided by 1 minus the ratio, if the numbers are getting smaller. So here we go. Second part of the assignment. Are these numbers getting smaller, or are they getting bigger? You guys are right if you're talking to the computer and at me. The numbers are getting smaller. We can find the sum. Sum equals first term divided by 1 minus r. That is it. First term, 3. 1 minus, we have to find the ratio. A divided by B, that's how you find the ratio. The one after divided by the one before. 1.5 divided by 3 is 0.5. 1.5 divided by 3 is 0.5. I'm going to simplify the denominator. 3 divided by, what's 1 take away a half? 1 take away a half is 0.5. 3 divided by a half is 6. That's the sum of this infinite series. The next one, what are these numbers doing? 1.3, 4, 12, 36. These numbers are getting bigger. No sum. I think we have one more, and I think we're done with today's assignment. Are these numbers getting smaller, or are these numbers getting bigger? Yep, they're definitely getting smaller. If they're getting smaller, we can find the sum. The sum equals the first term, 30, divided by 1 minus the ratio. How do you find the ratio? A divided by B. The one after divided by the one before. It's going to be 1/3. Or, if you do it on your calculator, 0.3 repeating. I like simplifying the denominator first. 30 divided by 1 minus 0.3 repeating. 1 minus 0.33333 is 0.666666666. So take 30 and divide it by 0.6666666, and you're going to get 45 for your answer. And that's all the worksheet. First part of your worksheet, tell me if it's a C or a D, converging or diverging, and then find the sum if you can. That's all the notes for today. Hopefully you're having a good day.